This video is a review of absolute value equations and inequalities. On your algebra inventory sheet, I'll be doing problems numbers 4 and 6, but before I get to those, I'll be doing some basic problems to try to warm you up and remind you how absolute value equations and inequalities work. So here's our first one, just the absolute value of x equals 5. An absolute value, for whatever reason, tends to be a scary topic for kids, but I just need you to think about this. Whatever's inside the bars, when we take the absolute value of it, has to equal 5. So if I just write some blank bars here, and I say the absolute value of something equals 5, what could I fill in the bars with to make that equal 5? Well, clearly, if I write a positive 5 there, the absolute value of positive 5 is 5, so that would work. But is there anything else that would cause this to be true? Well, negative 5 also works. The absolute value of negative 5 is 5. So this has two answers. X could equal 5 or negative 5. Two solutions to these guys. And the idea of two solutions is going to come up a lot in these absolute value problems. How about a greater than problem? Absolute value of x is greater than 2. Can you think of some numbers that would satisfy this? Certainly 3 would work. The absolute value of 3 is greater than 2. 5, 10, all these numbers have an absolute value that's greater than 2. 20. Are there any other numbers? How about some negative numbers? Negative 6. The absolute value of negative 6 is 6. That's greater than 2 as well. So how do we deal with these guys? Well, really the idea here is, think about where does the absolute value of 6 equal to? Well, we know that would happen when x equals 2 or negative 2. And really on our number line, what we're looking at here, if I draw a nice little number line for myself, here's 2, here's negative 2. I'm going to put open circles there because I can't equal that. Basically, any number that's greater than 2 will cause that absolute value to be greater than 2, but also any number that's less than negative 2 would cause that inequality to be greater than 2 as well. So the inequalities can be a little trickier, but we have to think about the endpoints. Here's another one. How about the absolute value of x is less than or equal to 4? Well, here's my suggestion, is to forget about this symbol for a minute and just think of it as the absolute value of x equals 4. We know already, if I draw a nice little number line, that the two numbers that satisfy that are 4 and negative 4. And I'm going to put closed circles there because this is a equal to problem. Okay? What numbers in this number line would cause this expression to come out as less than 4 when I plug them in? Well, 0 would, 1 would, negative 1 would, the absolute value of negative 1, that's less than 4 as well. And it turns out that any number in between here, between those two endpoints, will cause the absolute value to be less than 4. So now you're armed with all the information you need to do problems that are a little more scary looking, like this one. This is problem 4. Problem 4 from your worksheet. Absolute value of x minus 5, then plus 2 equals 8. And what you can't do is you can't take these guys and combine them. You can't combine something that's in absolute value bars with something that isn't. What you need to do is take this negative 2 and move it over to the other side. So I have absolute value of x minus 5 equals 6. Now the deal is, let me do a little erasing here. What if I erased all that? What would need to be inside the bars for this equation to be true? Well, we know 6 would work. We also know that negative 6 would work. Both those things would work. And inside the bars, I have x minus 5. Well, that means that x minus 5 has to equal 6, or x minus 5 has to equal negative 6. There are two potential solutions here, and I have to solve both of these. On the left-hand side here, I'm just going to add 5 to both sides. That means x could equal 11. Or on this side, I'm going to add 5 to both sides. X could equal negative 1. Two possible solutions here. And you can check them both in the original equation, plug them both in, and you should be able to verify that they both make the equation work. They are solutions. One last example. Here's an inequality. So this time I have to start by moving the 3 to the other side, and I have absolute value of 2x minus 1 is less than or equal to 7. I'm going to figure out the two endpoints. This means that 2x minus 1 could equal 7, or 2x minus 1 could equal negative 7. I'm going to solve both of these guys. I'm going to add 1, 2x equals 8, so therefore x equals 4. Or over here I could have plus 1, 2x equals negative 6, x equals negative 3. But those may not be the solutions. What I'm looking for are solutions to the original thing at the top here. What this means is that 4 and negative 3 are the endpoints of the solutions. And since it's an equals problem, I'm going to shade both of them in, closed circles. And I have to think about things that will come out as less than. Well, less than implies smaller. Think of it as in between. Less than problems are in between problems here. Everything in between would cause the original problem to be less than 10. And you can verify a couple of those. One last little thing. If I was given a problem that had a greater than in it, like greater than or equal to, I would do the same procedure, but I would shade the outsides. And those would be the numbers that cause it to be greater than. So less than problems, shade inside. Greater than problems, shade the two outsides. And you're all set to go.